one of the methods we've been using, it's called RL. So reinforcement learning, deep reinforcement learning, if you're using deep neural network to drive the reinforcement learning. But essentially, you're just giving a reward when the agent does something, the bot does something that you want it to do, and you're giving it a penalty when it does something you don't want it to do. And it's very similar to the way you would potentially train your dog or your cat.
Hey everyone, welcome to Dev Interrupted. I'm your guest host, Connor Bronsden, and today I'm joined by Josh Romoff, R&D scientist at Ubisoft. Josh, thanks for joining us.
Yeah, it's great to be here.
Yeah, we're super excited to have you on the pod today. We've never actually had a game studio on the show before, and Ubisoft is a massive name in the industry. 20,000 employees and over 45 studios, and you're responsible for some of the biggest gaming franchises in the world, like Assassin's Creed, Rainbow Six, and Far Cry, just to name a few. And I do have to admit here that I've spent way too many hours playing the Assassin's Creed franchise myself. So I'm really excited to dive in and get to talk about Ubisoft a bit. Before we start, though, do you have a favorite game yourself?
Yeah, I mean, for me, it's all about big open world games. So things like Zelda, Assassin's Creed, Far Cry, Skyrim, Fallout. Currently, I've actually been playing Elden Ring. So that's
I knew you were going to say that.
Yeah,
like, just given the time, I was like, okay, we know.
It's been a lot of fun. Yeah.
Nice. Yeah, I'm a bit of a mix. I love like the open world stuff, but I'm also really into some of the weird like RTS. So like I play a lot of Stellaris on my PC kind of thing as well. And then I'll do like Assassin's Creed, Elden Ring.
RTS stuff really kind of gives me anxiety because I don't know what's going on like the other side of the playground. So anytime I'm playing StarCraft or something like that, it's tough.
That's fair. It's fun that there's all these different experiences available across these different worlds, these different archetypes. And I suspect that some of the work you're doing at La Forge, the research and development arm of Ubisoft, maybe plays into how that creation happens. Can you maybe give the audience the Cliff Notes version of the role that La Forge plays within Ubisoft?
Yeah, for sure. So Cliff Notes version, Ubisoft La Forge, with a bridge between the academic world and the actual video game productions inside of Ubisoft. So essentially, we identify and work on interesting problems that interest both parties. So that's kind of the key. So we're not going to work on things that aren't interesting from a game production standpoint. We want to make sure that our research is very directed in the sense that if it works out, which it doesn't always do inside of research, that there's a path for us to basically implement what we've researched inside the game. And that's what kind of makes us different than other types of research, for instance. And we have offices all around the world, and we're constantly expanding and hiring.
So I'm really fascinated by this because I'll be honest, until prepping for this conversation, I really had no idea about the academic research ties with video games. What's the kind of research that links up with the different games that you're working on?
So on my end, and I guess I'm going to talk mostly from experience, we're really interested in building bots. And so bots as NPCs, so characters that you're interacting in the game, essentially, characters that you're interacting with. Bots that replace players potentially if they drop out of a multiplayer game. And so essentially building up these bots in games that are getting more and more complicated, and bigger, right? So as games get more and more complex and require more and more abilities and interesting little facets inside the game.
So it's really deep, like AI machine learning research within games. That makes sense. Can you tell us a bit more about these bots?
Yeah, for sure. So essentially, at least the ones that, there's different ways to train up your bot, right? So one way is we'll have a bunch of player data. So if you have a bunch of games that players have played, logged somewhere, then you could try to imitate the players, right? That's something that we can do, which is really cool. And it's one way to do it. The other way to do it is giving the bot some kind of objective and say, okay, your objective is to win the game. That's the most general objective, right? So if you're playing a shooter, it would be to eliminate all the opponents or something like that. But it could be as simple as navigate from here to a specific goal location. That could be your objective. And then the idea is, using AI, using different techniques that have existed for the last decade or two inside of the academic world. To essentially do that, using all the tools available to the players and to basically solve certain objectives that you want the bot to do.
And so it sounds like the idea is to solve the scalability issue of, okay, we can't have humans sitting around in game being NPCs. We need to have bots do it. So let's train them so that they can accomplish these tasks. Is that correct?
100%. So it's not that we can't build bots in games, right? Without some kind of fancy AI. I mean, if you've been playing games for several decades, then you know that, right? There's always been.
I'm thinking about like RuneScape bots, honestly.
Yeah,
like
exactly.
Yeah.
They've always existed, right? It's not something that's impossible to build. It's really is about that scalability problem that you mentioned. As games get bigger and more complex with more abilities that you want your bot to be able to handle, classical approaches kind of miss the mark in the sense that it'll be pretty obvious that you're playing against a bot, right? That's one of the first things, right? You're not, there's going to be limited abilities potentially, like you're not going to have your bots do all sorts of different things. And the overall experience might not be great, and it might not scale to the complexity of the game.
So I know you've talked a little bit about training here. Let's dive deeper. How do you train the bots to, achieve the level of complexity and depth that we want to see out of them?
So one of the methods we've been using, it's called RL. So reinforcement learning, deep reinforcement learning, if you're using deep neural network to drive the reinforcement learning architecture. But it's actually fairly straightforward to explain. But essentially, you're just giving a reward when the agent does something, the bot does something that you want it to do, and you're giving it a penalty when it does something you don't want it to do. And this is obviously all programmed in advance. So there are many different applications of this. It's a very general framework, and essentially what I did my PhD in, right? What I specialized in, and essentially, yeah. So say we're trying to navigate from one point to another on a map, then we'd give the agent a +1 reward when it gets to the goal. That would be the basic reward that we can talk about. And so the agent will just try to maximize that +1, because that's what they love doing, is maximizing these +1s and minimizing the -1.
Got it. So it's basically saying the system of +1s is used as like the reinforcement mechanism, because bots are like very binary about like, okay, is it right or wrong, +1, -1, or +1 or 0. So they have this constant improvement factor, it sounds like.
Exactly. And it's very similar to the way you would potentially train your dog or your cat to do something that you want. You give it a treat when it does some behavior that's really interesting and that you want it to reinforce, essentially.
Totally. I mean, for folks who are watching this on YouTube, you can actually see my cat next to me as I'm trying to get her to stop over grooming herself. So this is a very relevant example for me right now. I'm curious, we talked a bit about getting bots to actually act like they're players and kind of fill in if someone, their internet drops during a multiplayer sequence or something like that. How close are we to that? Or are we already there to let bots kind of take the spot of players?
Yeah, I think it's all about expectations. And so one of the things you give up with this type of approach is usually some kind of control over the deep reinforcement learning bot, the AI controlled bot. And so that's kind of where the interesting questions remain. It's not that we can't, you could put any system and just plug it in and say, all right, input some state of the world, output some action space, and go. But obviously, if you want to have that fine-grained control over the AI, that's kind of where there's a bunch of interesting questions. And also, how long and how much experience do you need this AI to train on, right? Because it needs to basically practice and get better at the game for a long period of time. So those are kind of the interesting questions. If you have enough time, right, these bots can get really, really good, superhuman even. And then it becomes a question of, is this even a good player experience for the player if they're playing against a bot that just beats them every time? That's maybe not that interesting.
Especially if the bot has more information or boosted a movement ability because it's just able to click faster kind of thing. Yeah,
exactly.
So what do you think the future of these bots looks like then? Are they going to replace players in some instances? Are we going to have to like kind of level them off? What do you see happening there?
Yeah, exactly. I think it's, it's going to be this iterative process. And I think it's going to be really interesting matchmaking players, starter players against bots that are of equal caliber. And this is something that's definitely...
So I've had that happen to me already. So
Exactly. And then, but it really actually has a lot of applications as well, even on the other extreme, right? If you're a pro player trying to play the game, then I think it would be really interesting to actually play against these bots that have kind of mastered all the techniques that you maybe haven't even thought about.
Interesting. I hadn't thought about it from the training perspective for humans. So, we're training these bots and now we can bring them back and say, okay, actually now let's use them to train humans to get better at this game or to really excel here.
Yeah, exactly. And I think there's varying levels of that, right? If you jump into a game, if you jump into a multiplayer game inside of Rainbow Six, for instance, Rainbow Six Siege, and you jump in. At least my experience was I just got wrecked by the other players, right? And so this is something that's not that enjoyable from a player experience, and so it's something that would be really nice to have a bot that's actually playing against you at an equal caliber, and so you could actually learn how to play the game properly instead of just being thrown into the deep end and hoping for the best.
Totally. I mean, to bring it back to the example of like RTSs that we talked very briefly about earlier, if you grew up playing, I don't know, Age of Empires or something like that, you know that like, yes, you can play it online versus other humans, but sometimes a very hard opponent is just, throwing it on hard mode and playing against the AI that's in there. And that's really what we're seeing now is like the extension of that into, okay, now we have multiple bots running around this like larger universe. So it feels like there's been this huge boost in the last 10, 20 years of where this research has gone and the success of it. Would you agree with that it's scaling very fast?
Mm-hmm. Yeah, for sure. Like I think it's scaling really fast. The tools that game devs have access to is also improving drastically. The amount of compute power that you have access to is increasing drastically, and all of these factors kind of have led to this almost, we're almost at the point where it would be almost seamless, like plug and play, train your DeepRL bot or train whatever bot you want, with just a click of the button.
So you may not even know if you're in like a multiplayer game, oh, this is a bot I'm facing. It's just like, here's another thing I have to fight.
Yeah. I mean, and I think that's the ultimate goal, which would be really cool, right? To at least from a researcher standpoint. I think from it brings up all these other interesting questions of, you should probably be telling the players that you're playing against bots because they might feel differently about these things. I think there's a lot of interesting complexities that myself as a researcher, I don't necessarily, I just want the bot to get to that level, right? That's my goal. And then I'll deal with those problems afterwards.
But you're right there are ethical questions and questions of like, what's the player experience like that we have to consider along the way. This is really fascinating. I do want to zoom back for a second and get to know you a bit more. I know you mentioned you've got your PhD, and I think that's really interesting to kind of dig into the academic research side of this. So La Forge is this link between gaming and game companies and academic research. Can you tell us a bit more about your background, what you studied to get into this, and how you took your first steps?
Yeah, it's actually really interesting. So when I started my post-school studies, I went to university, and my goal was actually to get into video games. That was actually my goal. So
you did it.
I wanted to take this one course. It was a 500 level course you can only take in your last year, and it was called Modern Computer Games or something like that. And that was actually the only goal I really had at that point in my life. And that was during my undergrad. And then essentially I graduated, and I still wanted to work in video games, but random luck of the draw, I ended up doing a master's degree in deep reinforcement learning applied to video games. So that was kind of the application side of things. And so what I mean by that is because video games are such a good application of deep reinforcement learning, because it's these, well, if you think about bots and games, like video games, it's such a perfect match because you could simulate the world at such a high frequency. It really lends itself nicely to the approach because you really need a lot of interactions with the game world. These aren't physical robots that are crashing into walls and stuff. And then I just continued on, did my PhD, and then applied to Ubisoft right after I graduated. And now I'm here. So that's kind of my background. I've always wanted to work in video games, and then the research side of things was very interesting, obviously. So now I've gone full circle.
Yeah, this is fascinating. I think part of what makes video games so unique for our audience is that most software developers are trying to find a problem, then figure out a solution with software. And in the case of Ubisoft, your main goal isn't to find and solve the problems necessarily. It's to enrich players' lives, but you're doing that on like an action by action basis to get to that goal statement of like enrich players' lives. And I know the Ubisoft website actually says like you're bridging the gap between academia and video games to help do that. But, and this is a kind of a counterpoint here, I know when we talked to you before this call, you said, 90% of academic research is useless. Can you kind of conflate those statements? How do those work?
Yeah, it's definitely something that you feel. I think anyone who's gone through the process of a master's degree or a PhD degree, you end up working through a bunch of research, you're reading all these papers. And in the end, I actually stand by that statement still when we were talking before, because I really do think that 90% of the research that's done, at least in AI, gets discarded. And what I mean by that is, it gets published at a conference, a journal, and maybe some people, a lot of people read it, but it doesn't actually get used in the real world. And so it's research for the sake of research a lot of the time. And of course, you need those. I'm not going to call them failures necessarily, but you need, you're not going to hit gold every time, obviously, but it's even bigger than that. It's really about being directed with a real problem at hand. And so that's kind of where we lie. That's where we direct our research. We're making sure we're trying to solve problems. We're not coming up with theoretical solutions to problems that may or may not exist.
Yeah, it sounds like what you're saying is that a lot of these theoretical solutions maybe aren't actually building on anything. They're just like exploring versus actually trying to, build a multiplayer universe with bots that you continue to build on and train. And then, by the next iteration of the game, they've improved again and improved again. Is that kind of what I'm hearing?
Exactly. So it's really about having that end goal in mind when you're doing the research. And I think that's what really has led to a bunch of different successes. If we're publishing a paper, which is something that we do, which is interesting too. Like we're not just staying internal with the stuff that we're doing, but we are sharing it. Then it's really only when we feel like, okay, this is a really solid academic contribution as well as a practical contribution for us.
Have you thought about going back and teaching a class on AI or something like that then, along with the work you're doing now?
So it's something that I do inside of Ubisoft, actually. So we actually have a bunch of courses set up, and that's something that I do every few months. We have an RL course that I teach, and there's also an ML course. So that's something that I do, and it is something that I've thought about to go back to the university and actually teach, because I think it is something that's fun.
That's awesome. That's fascinating that Ubisoft publishes academic papers, but it makes sense given the fact that you have this major background in research and obviously are doing a ton of research within the company to drive AI and ML forward. So given this like background in R&D you have and academic research, what do you view as like the key ways that the work you're doing is helping Ubisoft create better video games and enrich players' lives, as we said earlier?
Mm-hmm. That is the key question, essentially. Right? Because in the end, you work on a piece of research and you can get validated by publishing it at a conference, right? So that's something that we're working with students, we're working with professors, and the end result is essentially could be a paper that gets published at an academic conference or something that we're talking about. But the other key component of things is actually pushing it into productions and saying, okay, no, this improves what we're currently doing. So we're actually making, by design, that's the second step of the process, is that we're actually creating solutions that help us make better games. And that's enriching players' lives by results, essentially. So it's like if you can take a solution that exists and say, okay, no, well, with deep reinforcement learning, we could do a lot better. And then you hit that mark, publish a paper maybe, and push it into an actual production.
How do you make the decisions about what you're actually going to work on? So you have this inspiration from your academic research. How do you decide, okay, we're actually going to build this into, I don't know, Far Cry 6 or something like that?
Yeah. So that's kind of key to the whole process, actually. So it is really interesting. And that's essentially my job to some degree, because it's not that easy, right? Because there's a lot of pushback from both sides. So you have profs and students, they want to work on these very interesting theoretical problems that are, they're not necessarily, they're interested in video games because it's a really cool application, but they're not interested necessarily to make greater video games, right? That's not actually their motivation. And then from the production side, this is where the key part comes in. We're not going to work on something unless we literally have people from the production saying, okay, if that succeeds, this is something that I'm going to endorse. This is something that I would want in my game today, essentially. So we're going to have a phase one where we're working on a more toyish environment. And by toyish, it's still like a 3D game, but it's simplified. And then a phase two where we actually push into production. And that's something that's already been endorsed. So that's kind of the key. And by endorsing it, the people from the productions are staying up to date, with monthly updates, essentially on where the research is going, where it's headed, and they get to influence the actual research. And this is key, because when you stay in your silo, essentially, when you're staying on too far on one side or too far on the other side, you don't end up with a solution that anyone's going to end up using.
So what teams then do you work with within the company?
Yeah. So we have our group, obviously. And then within the company, we're going to have a bunch of partners with basically a bunch of different productions. So any production, any game, essentially, like we try to have close ties with as many as possible, because you don't know exactly who's going to want what at what time, right? So it's good to kind of keep your options open. There's also a ML engineering department that's kind of helps us kind of as the midway between us and the production, that are going to develop tools like integrating your neural network to run inside the game engine itself. That's actually not trivial at all. So running these neural networks inside the game engine is something that's fairly complex. So there's a whole team inside of Ubisoft that's dedicated to that. And they're amazing partners for us. So there's the game productions, there's the ML engineers, and then there's us as a research group.
So it sounds like you figure out what should be done, and then the ML engineering team kind of helps ship the tools that you're building. Is that correct?
Exactly. They're going to work alongside us and the productions, kind of like a partnership between the three different groups.
What kind of feedback loops have you developed to know if something is working well, for the production team, since you have to kind of have these layers to make it all work?
Yeah. So we're going to have different targets, different gates that we're trying to reach, essentially. And so on the research side of things, when we're still on the research phase, though, we still have those gates. And I think that's actually really important. It's really easy when you're working with academics and students and PhD students, that the project can just go on for years, right? A PhD can span 5 years or so. And so we don't want that, right? We want to have these clear-cut gates. And
got to ship at some point.
You got to ship, but it's like you got to ship, but at the same time, there's an understanding that it might fail, right? And so one of the things that we're kind of key on is like, okay, we have these gates that we're trying to reach. If we don't reach them, we don't move on to the next step. And so I think having that laid out in advance before we start a project really does help guide the research, and then sets everyone's expectations. If we're saying, okay, we're going to hit this gate in 3 months, it takes us 5 months, that's normal. We go on to the next phase, and everyone's kind of, okay, yeah, I understand. And keeping everyone in the loop on a monthly basis, essentially.
Could you give an example of a prototype you've built that has been used in one of the games?
Yeah, being able to navigate is something I touched upon earlier in our conversation. And that's
right.
Actually pretty key, because as games get more and more complicated, players have access to different abilities. And what I mean by that is that, you could jump in a game, you could actually jump twice potentially. So that's one thing that has come up in more and more games, is like in your first jump, you could actually initiate a second jump. Anyways, I'm getting into the nitty gritty details, but you can imagine that being able to navigate actually comprises of a bunch of different things like zip lines, teleports, grappling hooks, you name it, right? And that
I get lost in games. So this is on point for me. So
yeah. So essentially classical solutions to solve this, because of course we can navigate, if you played any game, a bot can navigate around a simple map, and it's gonna look fine. But if you've also like dug a little bit deeper, like say you're fighting against a bot, an NPC, and you go hang out on top of a cliff or something, the bot's gonna just hang out at the bottom of the cliff and just kind of not know how to get to you, right? It doesn't know how to get to you. It doesn't have the same abilities that you have. And that's actually a limitation. That's not actually by design necessarily. It's actually like, okay, no, this is a limitation of our NPCs, because our underlying navigation system can handle this. And so essentially, as you break away from the classical system, which is just navigating in a simple 2D space where you're able to move around in simple regions, deep reinforcement learning comes in. And basically what we've done is we've integrated a bot that sees the world kind of like a player does. It kind of has this like, it's able to see around it. It has this this kind of vision. It knows different things about the world. And then the key thing is it's actually interacting with the world on a virtual gamepad, kind of like the way a player interacts with the world. And that means that, yeah, it can chase you on top of that cliff. There's nothing stopping that NPC from just doing everything that you just did. And so that's actually has many applications, one of them being testing the game to see, is this reachable from this point? And that's really where we've used it. So it hasn't actually necessarily gone in front of players yet, because that has a whole other element of it. It has to be perfect. It has to look really good. And this is something that we're tackling right now.
So do you build like game specific solutions, or are the tools you make meant to work across several games?
Yeah, that's one of the key things. So essentially, we're not going to start off a project in our research group that is only applicable to one game. So it is really about being widely applicable. And so navigation is a perfect example of that, because every game is going to be, it's going to have some kind of navigation system. It's kind of how we tackle things. There's a bunch of different reasons for that. A few of them being, what you don't want to have is you start working on something, say the research hits a little snag. One of the productions goes, okay, no, we came up with another solution. Like, we're happy with what we're doing. And so we don't need it anymore. And then you don't want to say, oh, well, now I don't have a tech endorser is what we call it. And so we're stuck. So we really want to make sure we have at least like 3 to 5 different tech endorsers at the same time, which forces us to work on things that are transverse in nature.
With transverse, just to clarify, meaning across multiple like game universes, correct?
Exactly.
Gotcha. And it sounds like you mentioned like project endorsers are kind of how you drive the decision making around what to build. Is that accurate?
Yeah, 100%. I mean, they're very involved in the process, from the conception of the research idea to the whole process.
Fantastic. It's fascinating how robust this system is, because as you're kind of dealing with these multiple game universes and creating these tools that work across the board, I'm sure you have to deal with like different challenges working across teams. What are some of the ways that you and your team get challenged when you are trying to, solve something that maybe is with one lead sponsor and then a couple other sponsors are pulling in different directions?
That's definitely a really interesting point. And it's something that we're constantly kind of dealing with, but at the same time, because of the design, the way we kind of structure it, it's, research idea, research prototype, reach this gate. And then, so after that phase, it really would be work with a single or multiple productions, right? So that's kind of the key. And say then someone comes in and goes, okay, no, but really this is like if someone at that point comes in and says, hey, but really you should be tackling this, we'll try to integrate it, and test it out, right? So it's one of those things that we can easily kind of integrate, but at the same time, it wasn't part of the original mandate, right? So It's something that wasn't what everyone kind of signed off on. So we're okay if it fails. I think that's kind of the key as well, being okay with things failing and not promising.
It's an experimental team.
It's experimental by design. And if something doesn't work, it's key to work with people that are accepting of that and understanding you're not getting it's not going to be perfect. So it is robust and it is scalable in the sense that, you take your game, you plug in this bot and it's going to learn something really cool, right? But is it going to learn exactly what you want? This is one of the research branches that we've recently been embarking on, controlling the bot and making sure it could do all of these different things, these different like constraints. So navigate in one direction, but don't step in lava, or navigate here and look in this direction so you can aim your weapon while you're navigating, and incorporating all of these different constraints. And so, when you ask the question, that's the first thing that came to mind is there's so many different constraints that you want your NPC to incorporate. And so that's actually was one of our big research projects, is how do we incorporate these constraints with the system that we've had? And it's something that academic researchers haven't been tackling, because for them, it's all been about benchmarks. It's not about shaping NPC behavior. It's not about building the character that you want. It's about winning the game. And we're not interested in winning. We're not interested in just about winning. We're interested about building an NPC and building something that a game designer would actually want to have in their game.
How long are your typical build cycles for this? Is it something where it's like, a month from now we're going to have this done? Or is it, we're in 2-week sprints, every little chunk is happening?
So it kind of gets broken down, right? So we tend to target an overnight training for one of our bots. So assuming everything is working, then you launch your training and you're going to end up with a deep reinforcement learning bot overnight. That's kind of our target. Each different phase and adding different components into the bot, right, before you get to that point can take, like a month, 2 weeks. It depends essentially. But that's kind of our target, is to have a bot that you can click play and essentially can train overnight.
That's amazing. This has been a really fascinating conversation, Josh. I want to close this out with a couple of fun questions here. So I'm curious, if we had to pick a video game character that you would want on your team to come, help you with your R&D research, or just, I don't know, brighten everyone's mood, who would you pick?
So to brighten everyone's mood, that's a whole different ballgame. I mean, the truth is, I can't actually have any of these video game characters on my team. For technical.
Well, you kind of can in the game.
I kind of can. Desmond Miles from the Assassin's Creed franchise would be really cool.
Oh, that would be really dope, actually.
That would be really dope. But I mean, again, the type of team members that we want are really, it's about determination and really like the desire to, like, you have to be motivated, you have to be passionate about what you're working on. I think that's kind of the key. And so I think that's kind of what I would really strive for in any team member.
You're making me think of Link now, honestly.
Yeah,
like,
that was my second choice. Would have been Link, just because we're working on deep reinforcement learning, we're working on AI, we're building AIs, but in the end, we're actually, building better games, right? That's what we're after, and so that actually has been a key discriminator for me. If I'm interviewing someone and they say, "Oh, I'm an expert in deep reinforcement learning. I'm this, I'm that," and I say, "Well, are you passionate about video games?" Right? That actually is a genuine question, because from my experience, at least, that does actually change the overall output and how people go about their day to day. And are you just happy every day waking up, just working on building it up an NPC and bot? And I am. So that's what drives me on the day to day, and that's what I want out of my team members, essentially.
Well, that brings me to another question then. Is your team hiring, or is the team that's, building your solutions hiring?
100%. Ubisoft La Forge, we have offices all around the world, as I mentioned before, and we're hiring at each of them. It's a global expansion, so to speak. So yeah, we're constantly hiring and looking for great people.
Awesome. And for Ubisoft, just that makes me think of something. Is it a mostly in-office culture? Is it hybrid? How's it set up?
Yeah, so that's actually a really good question. Obviously, with the recent COVID pandemic, right? So things have changed. I think our R&D lab as a whole has this really close-knit, small vibe, and that's what's really nice about it. So right now it's hybrid, work from home, or go into the office. You kind of have the option for both. So currently I'm working from home, but
that's not your office back there. Okay.
No. Yeah.
Awesome. Well, Josh, this has been great. I've really enjoyed this conversation, and it's honestly making me itch to go pick up a game controller or download something new on my PC here. So thank you so much for coming on the show. I hope everyone in the audience is going to enjoy it as much as I have. And I just do want to give a quick reminder for our listeners as well. If you haven't already rated and reviewed the show in your podcasting app of choice, particularly Apple Podcasts or Spotify, please do so. I know I say it every week, but reviews are a crucial way that our show gets discovered. And I hope you enjoy us enough to give us that 5-star rating. We'd really appreciate it. If you want to continue the conversations we're having on the show, if you want to talk to some of our guests, you can join us in the Dev Interrupted community. Conversations like this are happening all week, every day. We prompt a discussion. Plus, we have our interactive events. The next one's coming up October 25th. Our most recent one had more than 1,700 dev leaders join us live for some incredible content. We hope you'll continue to stay with us. Plus, a big thank you to everyone who is subscribed to our weekly interruption newsletter. We're over 3,000 people now who subscribe to that. We're bringing you articles from the community, inside information on our weekly podcasts, and much more. Maybe something fun from the Ubisoft community about games and how they're using AI. We'll try to share some research there as well, because I think it'll be fascinating. There's links to all this in the description below, and can't wait to see you next week. But Josh, thank you so much for this conversation.
Thanks for having me.